Welcome to Chemistry 111 Exam 4 Wrapper. Okay, so the first question we have is about classifying different types of electromagnetic radiation. And so here it says, which of the following electromagnetic radiation has the highest energy? So E equals H nu. And so energy, if you increase energy, it also correlates directly proportional to increasing frequency. And so if you look here, 10 to the 4th is this is a lower frequency, and 10 to the 20th power would be a higher frequency. So, and this is showing you here. So ultraviolet is right here. Visible is right here. X-ray is right here. And microwave is here. So the answer for this question would be the X-ray, C. How many orbitals in an atom can have a 4p designation? Okay, so how many orbitals? So orbitals are where the electrons are found. And so if you have a 4p, then you have 3p orbitals. And so how many electrons could have a 4p destination? 1, 2, 3, 4, 5, 6. So that's how many electrons can be. So this is 6 electrons can be in this 4p, but the box, if you remember, the box is considered an orbital. So this is 3 orbitals. 3 orbitals. And this correlates to if L equals 1, because P is 1, then M sub L is a plus 1, 0, minus 1. This could be a plus 1, 0, minus 1. So the answer is 3. Okay, this is electron configuration. Which of the following elements have a ground state electron configuration? Now I have my periodic table out, so I'm looking at my periodic table, and this is the condensed or shorthand. So I'm going to go all the way to argon, and so I see that argon is 18. So number 18 electrons, that's the noble gas. And then I go to 4s2. So 4s2 gives me the calcium. 3d10 gets me all the way to zinc. And then I'm at 4p5. And 4p5, when I count over 1, 2, 3, 4, 5, I'm at bromine, which has 35 electrons. And you can add these electrons together. So if you have 18 plus 2 plus 10 plus 5, I'm going to go ahead and get my calculator out just to demonstrate. So 18 plus 2 plus 10 plus 5 is 35 electrons. And 35 electrons is also element 35, which is Br, bromine. Which of the following elements have a ground state electron configuration? Okay, we just did that one. Okay, so then, that the one? Yeah, so we just did that one. Okay, what is the wavelength in nanometers of the red light emitted by a barcode that has a frequency of 4.62 times 10 to the 14th reciprocal seconds? So this is a frequency. Frequency is in the units reciprocal seconds, and it's asking for wavelength. So C equals lambda nu is the formula that you remember. If you look at the periodic table, you can see that c is given to you, the speed of light, and is 3.00 times 10 to the 8th meters reciprocal seconds. That is just the 2.9979 times 10 to the 8th meters for reciprocal seconds rounded. So you can use whichever one you want. And it has a frequency, so V nu is 4.62 times 10 to the 14th reciprocal seconds. And since we are matching the units here for C, we don't have to manipulate the nu. And so you want to isolate the wavelength because that is the question, the wavelength, and it wants it in nanometers. So wavelength equals C over nu. So 3.00 times 10 to the 8th meters reciprocal seconds divided by the frequency, 4.62 times 10 to the 14th reciprocal seconds. Reciprocal seconds is going to cancel out. Make sure you can use your calculator to do the exponents, because mine you have to do second e to the 8th. I'm going to divide that by 4.62, second to the e to the 14th power, and I get 0, 0, 0, 0, 0, 0, 0. I think that's 6 zeros. 1, 2, 3, 4, 5, 6, and then 6, 4, 9. That is meters, folks, okay? And so it asks for nanometers, so I've got to convert 0.0000000 60649 meters into nanometers. So for 1 meter, we have this 9 zeros for nanometer. And so I'm going to take that number and I'm going to take it times 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I get 649.35 nanometers. And you can see that that answer is A. Also, this is the open response question number 20. So you will not see me work that. That is worked right here. All right, so the next thing I would like for you all to be able to do is to do the orbital diagram description. So these are with the boxes. And so this is also condensed because we have argon here. So that's 18 electrons. 18 electrons for argon. So you find argon on the periodic table. And then you see, okay, you have 4 electrons in the 4s2. So that's calcium. And then with 3D, you have 1, 2, 3, 4, 5, 6 electrons. So this is 3d6. 3d6. So I'm going to count over 6 from calcium. 1, 2, 3, 4, 5, 6. And that puts me at iron. That is in the D block, which is obviously the electrons, the outer shell electrons are in the D block. Just to double check, I like to add up all my electrons. 18 plus 2 plus 6. And that's 26 electrons, and I look, and that's also correlates to iron. So it's a double, it's a check. So iron is here. Now, if you look at nickel, if you look at nickel, okay, so nickel also with 2 plus has 26 electrons. And cobalt has also 26 electrons. Calcium has 20 electrons. So why did I not pick cobalt and nickel? Well, if you had cobalt and nickel, so cobalt would be argon, and then so cobalt would have, so let's do this here, 1, 2, 3, 4, 5 orbitals. This is 4s, this is 3d. So if you just did regular cobalt and you look and you're like, okay, cobalt has 27 electrons. So this is 18 for argon, and then you would say 1, 2, 3, 4, 5, 6, 7. Lost my count here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, so that would be 27. 8, let me double check, 18 plus 9, that's 27 electrons. And then if you subtract 1, because it's a plus 1, so cobalt plus 1, folks, you would have to take it from the 1 from the 1s. So you would have that right there. Okay, so cobalt plus 1 would be argon, this electron configuration, 4s1, 3d, 5, 6, 7. And then nickel plus 2 would be argon, and you lose 2 electrons, so 4s0, 3d, would that be, I guess 7. I don't know, I'd have to look at nickel. Nickel would be, I think, 8. That would be 8, yeah. So you see that since you have these electrons in the 4s, it has to be ground state iron. All right, and so the next thing we're going to look at, I'm just going to give me some working space here, folks. The quantum numbers. So we've talked about quantum numbers. Which set of quantum numbers cannot occur together? So can you have a 2 if L equals 1? So L equals 0 is S. L equals 1 is P. L equals 2 is D. L equals 3 is F. Can you have a 2, 1? So can you have a 2p orbital? And m sub L means if you have a p orbital, you have 3 orbitals, and m sub L would be plus 1 minus 0 minus 1. So yes, you can have that, and if you look, you can see that on the periodic table there is a 2p block, and if L is 1, then m sub L can be 1. Okay, let's go to the next one. Can you have a 3? So that's row 3. L is 2, so D. And then if you have d orbitals, you have 5 of them, right? 1, 2, 3, 4, 5. And so if L is 2, then this is a plus 2, plus 1, 0, minus 2, or minus 1, minus 2. So you do have a 0, and that is fine. So B is fine. We're looking for what we cannot have. Okay, we can't have a 3. We can't have a 3F. Okay, you have to have a 4F. The L has to be 1 less than the N number. So the answer is C. That these are the answers here. But just to go through the next one, let's just look at that one. Like I said, the answer here is C. You can have a 4F, and then 4F you have 5 orbitals. 7 orbitals. 1, 2, 3, 4, 5, 6, 7 orbitals. And this would be a plus 3, plus 1, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So that is allowed. Okay, you also need to know the orbital shapes. And so if you look at here, this is an s orbital. That would be L equals 0. This, I think, would be a d orbital. So that would be L equals 2. This would also be a d orbital, and that would be L equals 2. And this would be a p orbital, so the answer is D. And the p orbital is L equals 1. Okay, so now we want to write the electron configuration for selenium. So if I go and find selenium, I see that that's number 34 on the periodic table. And so I look to find the mole gas before, so that's argon. And argon has 18 electrons. And then I come down from argon and I see we have 4s2, which gives me to calcium. Then I have 3d10, which gives me to zinc. And then I have to get to selenium, which then would be a 4p. And then I count over to selenium, 1, 2, 3, 4. That's a 4. And so that gives me to selenium, I'm also going to total up those electrons. So argon has 18, the S block has 2, the D block has 10, and then we have 4 in the P block, and that does match 34. So now I want to go here and see, it looks like, and I'm going to make sure that they're not, like this one's, if you see this one here, you see that there's not even numbers there. Numbers are missing. Um, so this one is not the right noble gas beforehand. This one is missing some P's, and this is not the right one. So A is the answer. Now you also want to be able to do electron configuration for the ions. Okay, so basically what I do is I just go straight for the iron, and I like to do these in orbital diagrams because you're going to be taking away 2 electrons. So we're going to do regular iron, and then we're going to take 2 electrons away. So I go and I say, okay, iron or argon is 18 electrons, and then we go the 4s2, and then that gets us to calcium, and then we have 3d. I'm going to put the five orbitals there, 1, 2, 3, 4, 5, and then I'm going to get to iron, 1, 2, 3, 4, 5, 6. That's 3d6. I'm going to put the electrons in, 1, 2, 3, 4. Well, there's 2. I'm going to do 6. 1, 2, 3, 4, 5. And then I'm coming down with the other one here. Now, when I do iron 2 plus, I've got to take electrons away. So I'm going to take these 2 electrons. I'm going to take them away because I have to take it from the highest energy shell. And the shell is 4 is higher. So argon, and then you could do 4s0 because there's 0 electrons there, and then the 3d6. So now if I look for this, 4s0, 3d6, I see that C is my answer. All right, so which of the following elements would you expect to have the greatest affinity, electron affinity? Okay, so I told you there was about 4 trends that I'm going to ask you about. And so electron affinity, these are a love for electrons. They want to accept electrons. And so these elements that are going to accept electrons, they are going to form anions. So you're going to look at pretty much your nonmetals. So on the periodic table, it's up here. It's up here in the upper right-hand corner. And it's not going to be any of your noble gases because they're not going to accept electrons. But like fluoride, oxygen, nitride, phosphide, sulfide, chloride, bromide, iodide. These are the elements that have affinity. So it's not going to be noble gases. Lithium tends to form a +1, calcium a +2, so they lose their electrons. Boron, pretty much a +3, but boron's going to be out of this group, magnesium 2+. Electron affinity kind of follows electronegativity. This is electronegativity. And so I just do increasing electronegativity up and over. So these have the highest if you go across the row. So in this group of selection, I would say boron has the greatest electron affinity out of that group because boron would be up and over. All right, which of the following are iso? Let's go ahead and go down to this one since we're doing electronegativity and it follows electron affinity. Which of the following elements have the greatest electronegativity? Well, where's sodium? Sodium's here. Aluminum is here. Phosphorus is to the right of aluminum, so phosphorus would have greater. Cl would be greater than that, and argon is a noble gas, so Cl would have the greatest electronegativity in this group. All right, the other ones, let's do valence electrons and oxygen. You just basically look at the what group is oxygen in. It is in group 6A. So it has 6 valence electrons. You could do, um, so neon or helium. Helium is electron configuration 2s2, 2p4, and then you could see that these are the electrons in the outer energy shell. Outer energy shell equals 2, and that is 6 electrons. And those are your valence electrons, which are the outer shell electrons. All right, so let's do this one. We're working backwards. Which of the following ions have the largest ionic radius? All right, so these need to be isoelectronic. And so sodium, you can go find sodium on the periodic table and go back one, and it's isoelectronic with neon. Fluoride is isoelectronic with neon. Calcium is isoelectronic with argon. Uh, Bromide is isoelectronic with krypton, and potassium is isoelectronic with argon. So actually, um, this one, since they're not all isoelectronic, you need to know that one, the anions are going to be bigger, and two, krypton is also bigger because it's in, so the Br minus 1 is in the greater N number, which is row number 4, and the other ones are smaller. So that would be bromide. Remember, anions are going to be smaller or bigger because of the effective nuclear charge, and they have less number of protons for how many electrons they have. Which of the following isoelectronic same configuration as argon? Well, you could just look at sulfur and add 2 electrons, and that's going to be argon. So that's isoelectronic. Fluoride is going to be isoelectronic with neon. Sodium, you go back 1 to the noble gas of neon. Bromide is isoelectronic with krypton. And iron is not isoelectronic with any of those noble gases. So the answer is A. You could go and draw out the electron configurations for each one of these, and the ones that have the same as argon, which is, you could do the long one for argon is 1s2, 2s2, 2p6, 3s2, 3p6. And that would be the full electron configuration for S2 minus. Which of the following element ion is isoelectronic with sulfur 2 minus? Like I said, that's 1s2, 2s2, 2p6, 3s2, and then 2p or 3p. Sulfur would be all of these, which is neon, and then 3s2, 3p4, but when you add 2 electrons, 2 minus, then it's neon, this is 2 minus, neon, you're going to have to add 2 electrons, 3s2, 3p6, and that matches argon, and that's what we were doing here, 3p6. But sometimes when you do these, it's easier to start with the element that's neutral, and then you can add those electrons. So which one would be that? You could see that Clu minus 1, you move it one place, that's argon, so it would be A. Neon's not. Magnesium, you move that 2 places back, that's isoelectronic with neon. And then sulfur is here, so obviously it is not isoelectronic because it doesn't have the same number of electrons and therefore would not have the same electron configuration. Okay, so in open response, you're going to have to draw some full electron diagrams. So for sulfur, we just looked at that. Sulfur has 16 electrons, and then you'll want to do 1s2, 2s2, full orbital diagrams. You want all the boxes here. You're going to deal with 2p6, I'm just going to give it some working space. And then we're coming down to 3s2, and then we're 3 orbitals for 3p, and then count your electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 4. And you can see it's the fourth element in the p block, so that's also correct. And what I want to see when you do these is that you're getting your parallel spins correctly. So here you would go full Hund's rule there, and then you would come back to the degenerate orbitals. And so you're going to be able to see it here with 4. You're going to see that these are all parallel and they fill up the orbital, and then your fourth electron needs to come there. So that will be important to see that. Okay, and then nickel +1. So like I said, I like to go with nickel first and then take the electron away. So when we look at nickel, we have 28 electrons. And that's also why I picked nickel +1. You'll see. And we got to do the full, so we got to do the 1s2, we got to do the 2s2, we got to do the 2p6, there's 3 there, we got to do the 3s2, and then we do the 3p6, and then we do the 4s2, and then we're going to do the d, 1, 2, 3, 4, 5, 3d, and then if you look at nickel, you have, I'm going to count where nickel is in the D block: 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. And you can go ahead and put in your electrons for nickel: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Now, that's for nickel. But when you remove an electron, when you're going to remove an electron because it's nickel +1, you have 27 electrons. And the key is you've got to remove the electron from the 4. So I'm going to just, my eraser's not working. So what this would be 4s1. And then you would just have 1 electron in there. Okay, so this one, nickel, would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d8. And then you might want to add up all those electrons and see that 2, 4, 10, 12, 13, 14, 15, 16, 17, 18, 19, 19 plus 8, I'm getting the calculator out now. 19 plus 8 is 27 electrons, which is correct. Okay, so we have a few more of these to do. And okay. Write the full electron configuration for calcium. So this is just electron configuration, so I wanted to see that you don't have to write the orbital boxes. So calcium is how many electrons? 20 electrons. And this is ground state, so you just do it, and it's full. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay? And then for fluoride, you have how many electrons? You have 9 for fluorine, and then you got to add an electron, 1 electron, so you got 10 electrons. And so for fluoride, you would have to do 1s2, 2s2, 2p6. And then you want to also just double check these. 2, 4, 10, and there's 20. So you add those up here. 2, 4, 10, 10. So it matches. And so that's just electron configuration, so you don't have to do the orbital box. You don't have to show the electrons. This is the abbreviated orbital box. So I want to see that when you look for copper, I would just go straight with copper first whenever I do my ions. It is electrons number 29 for copper, and it's shorthand, so I've got to go on the periodic table and look at the noble gas before copper, which is argon, and then I come down and I say, okay, copper is in the fourth row, so now we got 4s2, and then it's 3d, and I'm going to count over to copper. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's 9. That's copper. But notice that we want copper 2 plus. So copper 2 plus, we need to remove the 2 electrons from the 4. So copper 2 plus is argon 4s0 3d9. And that is the electron configuration for copper. Titanium is in its ground state. So titanium, I'm going to look for that, and I see titanium is Ti, and that is number 22, so we got 22 electrons. The noble gas before titanium is argon, and then I'm going to come down to the fourth row and go 4s2, 3d2, and then I'm going to check 18, 19, 20, 21, 22, the electron count matches. Okay, so like I said, I'm not going to do 20 because 20 was worked out earlier, but this one I just want to show you E equals h nu, and you do this calculation. H is Planck's constant, so you look for Planck's constant here, and it's 6.6261 times 10 to the negative 34 joules times second. So V equals nu. This is nanometers, so that's wavelength. And so we're going to have to solve C equals lambda nu. We've got to solve for nu. So then you do nu equals C over lambda, and C is 3.00 times 10 to the 8th meters reciprocal seconds, but wavelength needs to be in meters. It's in nanometers, so 552 nanometers. We've got to convert that to meters because of the speed of light. So now we're going to do 552 divided by 1, 0, 0, 0, doing 9 zeros. That gives me 1, 2, 3, I think 6 zeros. 1, 2, 3, 4, 5, 6, 552 meters. I'm going to put that here for wavelength. 552 meters. You see meters are going to cancel out, and that's going to leave me with reciprocal seconds. You need to show all your units for full credit on the open response. Now I'm going to do this exponent to the 8th divided by 0.000000552. That gives me 5.4347 times 10 to the positive 14 meters. Not meters, reciprocal seconds, because we're dealing with nu. So then I can do E equals 6.6261 times 10 to the negative 34 joules times second times 5.435 times 10 to the 14th reciprocal seconds. The reciprocal seconds and seconds are going to cancel out. And when I do that, I get joules. E equals 3.60. We can just do 3. So 10 to the negative 19 joules. And that is the energy. Don't worry about 1 mole of photons. That's if, like, E in your book, you get N times H nu. N would be if you have more than 1 photon, and it's in moles, and I'm not going to do that. So you just be able to do E equals H nu, and I will be satisfied with that. And that wraps up your exam wrapper. Be sure to work any such problems that I might give the next time you're in class.